This week, Caddx have pushed out a couple of big updates for the Avatar HD system. We have a new VTX, which they're marketing as being ideal for racing, and we also have a new firmware that adds a race mode as well as improvements to the OSD. Now, in this video, I'm going to give you an overview of the new VTX and what has changed, and then we're going to spend some time talking about this new firmware and this race mode and how it differs from the original mode on Avatar HD, but also a few things that you may need to be aware of specific for racing applications. Now, the first thing we're going to do is talk about the race mode, then we'll move on to the VTX, and then we'll take it all for a bit of a flight, and I will share with you my thoughts on both the VTX as well as the new race mode as well. Okay, now to talk about the new update first of all, if I show you the release notes, I'm not going to go through absolutely everything, but you can see here there's quite a lot of improvements. We've got the new race mode, which we'll come on to in a minute. We've got camera improvements. They've introduced a new dynamic noise reduction feature. We've got OSD improvements, support for the dynamic coloured warnings in Betaflight, as well as a number of other changes around iNav. We've got improvements on the DVR, and overall, there's quite a lot of real nice bug fixes here. Now, the big new feature in all of this is race mode. This is a dedicated mode on the Avatar HD system that you actually have to switch it into. When you do that, it makes a number of changes on the system. Number one, the system reduces its resolution down to 540p. There is no option to use it in 720p or 1080p in race mode. It also fixes it in 25 megabits a second mode, low latency. You cannot use 50 megabits and you are stuck in the low latency mode, which really isn't a problem. It also realigns the channel allocation to conform to race band on analog. It doesn't add analog channels to the goggles, it simply changes the channel allocation from that original DJI style channel allocation to race band. You've got R1 through 8 as well as RP. Now, the whole idea of this dedicated race mode is to fix the system at a lower resolution, and Caddx say they've been able to tweak the system to try and improve the latency performance. Now, just to be clear up front, this new race mode is not fixed latency. The overall behavior of the system is exactly the same. It is still a variable latency system. However, race mode does appear to have more stability in good signal with regards to the latency. It should be less variable, and I'll talk about this a little bit more in my conclusion at the end of the video from all of my testing. More than anything, the idea of this is to try and give a mode that offers better latency stability at a lower resolution and conform to the race mode channels. Now, this will obviously raise a lot of questions about what else has changed, what is the situation with the RF behavior, has there been any improvements with regards to how the goggles work, and I've been doing a lot of testing on that since this firmware released. As I mentioned, whilst the system moves over to the race band channels, the Avatar HD goggles can still not receive analog. It works exactly the same as it did before. It is a digital only system. Also, there has been no great changes to the overall RF behavior of this system. So that means the goggles are still the primary part of the system that transmit as soon as you turn them on. When you do turn them on, they will either default to channel RP or the public channel when you're in the normal mode. That will still, though, transmit in the low power mode on that channel. The system also hasn't changed the behavior with the goggles stay on the channel you left them on last when you power your aircraft down. For instance, if you're flying and you're on R1 and you land and power down the aircraft, the goggles will continue to transmit on R1, unlike the original DJI system that used to hop back to the public channel when you power down the quad. Avatar stays on the last channel you left it on, and in a race situation you could have people come, fly, land, leave their goggles on, and they would all be still transmitting on the channels that they were using last. The only time the Avatar HD system hops back to either RP or the public channel is when you reboot the goggles, and it is something I think Caddx still need to work on. As I mentioned in all of that, nothing has really changed with regards to what transmits. The goggles are still the primary driver of the system, unlike DJI, which is the VTX. So when the VTX is off on Avatar HD, the goggles still transmit. Whereas on DJI, when the VTX is off, the goggles output zero RF information at all. And they have introduced a low power mode on these now. However, it is still fully transmitting on the last channel you were using, or RP or the public channel when you power it up for the first time. Now, with regards to compatibility, race mode pretty much works exactly the same as the other modes. So it works on the Avatar HD goggles, it works on the Avatar HD VRX module. It is worth noting though that you do need a goggle capable of supporting the 100 frames a second, i.e. the HD0 goggles, and it works on all the existing VTXs as far as I can tell, including the new race one, but you don't actually have to have the new race VTX to use it. You can use it on your existing ones. You simply go into devices, switch the system from normal to race, and then you're able to use it. So even if you don't have this VTX, you can go and try this out. Now, the next thing we're going to do is hop over to the new VTX. I'm going to walk you through that, and then at the end, I'm going to come back and share with you my thoughts on this new race mode, as well as the VTX, having actually spent some time with it in the air. So Walksnail have released what they're calling their Avatar Nano HD Kit version 3. If we just flip the box over, they actually call it the Avatar HD Racing Kit version 3. It is a new VTX. There's a camera, it includes an antenna, USB cable, and instruction manual as well. When you open the box, you'll find this VTX inside. You get the same USB cable like we saw on the V2 VTX, as well as the Whoop one. You get a camera mounting kit as well as an antenna included in the kit. Now, taking a look at what's actually new on this VTX compared to the others. Now, as you can see, it is a fully encapsulated VTX with a heatsink on the top and a metal plate on the bottom, but it is smaller than the other VTXs, and actually it is roughly the same size as the Whoop VTX that they released a little while ago. Actually, it's not roughly the same size, it is exactly the same size, and we'll take a closer look at that side of it a little bit more later on when we tear this down. Now, the first big change is obviously that it is fully encapsulated. However, there is a lot more going on here than it being just this VTX in a casing. This one supports up to 500 milliwatts of RF output. It has an increased voltage range from 3.1 to 13 volts. It also supports a new mode that is coming out with this VTX at the same time, which is 540p 100 frames a second, alongside the usual modes of 720p 100 and all of the other options. It comes with a 14x14 camera. This is similar to the camera that we originally got with the Whoop, but it isn't quite the same, and it weighs roughly 3 grams, and the whole weight of the kit that you've got here is coming in at 19 grams, making the VTX as you see it housed at about 16 grams. Now, you could decase this, and that's obviously going to drop the weight down dramatically. That is going to come in roughly then the same weight as this one here, roughly 6 grams. I haven't actually weighed this one without the casing on, but it is basically identical, but it does have the heat spreader on board, and that would be around that 6 gram weighting, showing you that there is a lot of weight savings to be had if you wanted to go down that road. This VTX also comes with the 32 gigs of onboard storage, meaning that you can use the onboard DVR just like on the V2, although you're getting the 32 gigs as standard here. Size-wise, this VTX comes in at roughly 31.8 by 31.8 by 7.2 mil deep. That 7.2 is to the flat area at the bottom and the top of the heatsink. There is a little bit more depth with the screws, but you could remove them to get that down. Now, mounting pattern-wise, the center ones are 20 by 20. They're not holes that go all the way through. They're only on this side of the heatsink. You can see there, they don't go all the way through to that side, just like on the V2. But you do have 25.5 mounting on the outside that does go all the way through. So depending on what frame you've got and what mounting options, you should be able to choose the one that best suits your needs. Now, the camera that comes with this kit has a native 4x3 sensor, has a 160-degree field of view, and it weighs just 3 grams. And it is a camera that works in the new 540 mode, but also the normal 720p and 1080p modes as well. Now, taking this new VTX apart is fairly simple. You've got the 2 metal covers. You've got a bottom plate, which goes over this side. That has some compound around the memory area, as well as the RF chipset. And then on this side, we've got the main system IC, and you can see we've got a deep cover here and a shallower cover here, and they're held in place then with all of the nuts and bolts that go through the casing. So let me just pop them there, with the restraining straps as well. But taking it apart is fairly straightforward, not really any different to what we had to do on the normal larger VTX. Okay, now just giving you a closer look at the PCB. Now I'm comparing it here to the Whoop board that Walksnail have made. This is the 1S version. You can see that it is very, very similar in how everything is laid out. We've got our main system IC here. We've got our dialogue voltage regulator. That's the 4 output regulator. We've got our bind button, but you can see that there are some differences. There's an extra IC here, and that'll be largely because this VTX has a different voltage range to this one. This one is up to 5.5 volts, I think it is, whereas this one does go higher. This one will go up to 13. Flipping it over, again, you can see everything is almost identical. We've got our memory, we've got our RF front end chip, our UFL, our power amplifier, and whilst there may be some very small differences, overall the layout of the board is exactly the same. Now, I've already uploaded images of this board onto repair.wiki, so if you're interested in finding them, there will be a link to that in the description below. Now, I'm going to be testing this in my Thug FPV frame. This is one of my older ones, but it's one of my favourite ones as well. It's one of the ones I tend to use as a modification frame and a testing frame. I've mounted the VTX here at the back. I've had to 3D print a bracket for it because I don't have anything on this frame. It doesn't have mounting holes, and I've just made a quick TPU bracket for the antenna there as well. And then we've got the camera mounted up front on these TPU brackets too. So what I'm going to do is finish getting this together, and then we'll take it for a test flight. Now, this is just an initial test flight to do a shakedown. The idea of this is for me personally to get an understanding of how this new 540p mode works, how it behaves, and how the compression behaves compared to the previous versions of the Avatar firmware, but also the effect of having that reduced resolution but at 25 megabits a second, and what the bandwidth they've got left is actually being used for. Is the compression behaving the same as it was before? Is it changing? And then I'll move on to some more tests around things like penetration, and I'll explain my findings in a bit more detail later on. Now, I've been doing a lot of testing on this for a few weeks actually, and I've updated all of that for the new release firmware. And one of the things I wanted to understand was the penetration behavior difference between the Avatar firmware in 540p mode and 720p. And I've been doing testing in my normal area where I have a real good understanding of how it performs, just moving it around behind the trees and stuff like this. And in my testing so far, 540p doesn't quite hold up as well as 720p with regards to penetration. It breaks up a little bit differently, but it certainly doesn't push on through quite as much as the 720p mode. Now that sort of makes sense because it would imply that they're actually using that additional bandwidth in the codec for having less error correction over the air and more error correction within the initial signal itself. Now, I've also done a bunch of testing to try and understand the latency behavior, trying to fly the same tracks and the same areas, and I'm not going to show too much on this now. I'll give more opinion on my findings rather than actually showing you differences, but here there are two flights that had very similar runs. Yes, there's a bit of difference between them, but what you can see is the latency differences between them. On the race mode, the latency is very much pegged at 23-24 milliseconds, whereas on the normal mode, it's more pegged at 25-26. And if we take a look at these charts of the actual latency numbers from flights, you can see the difference between this one, where it is pegged much lower in race mode, and then the normal mode where it does move around a lot more. And this all really falls into my findings of the fact that race mode is still variable, but what it does is hold the latency lower as long as it can, and then when it can't, it then moves back up the scale as it did before. Now, one last thing I just wanted to quickly show you was how HD0 540p looks compared to Avatar HD 540p. Now, whilst these flights are not designed to be identical, they are done at the same time of day. They are literally back to back, and I just want to give you a visual look of how the systems perform differently, but also you will notice a little bit as well on the penetration difference between them two. I do go behind the same bushes I went behind earlier on HD0, and I certainly can't get remotely what we can get on the likes of Avatar HD, and again, that is to be expected when it's not a two-way system. Okay, so to share with you my thoughts on both the new VTX and camera as well as the new firmware and race mode. Now, hardware-wise, I really like the camera. Native 4x3, image quality is actually really good, no complaints at all. With regards to the new VTX, it's good to see. This is basically a version 3 Whoop VTX. It is the same board, couple of little layout changes, increased voltage range, increased PA, which gives a bit more power, but I think this is just going to end up replacing that original version 2 Whoop VTX. We've had the first one, which was bigger, the second one, which comes without the heat spreader on board, and now we've got this same PCB layout, same size. The only difference here is that we've got an extra couple of 100 milliwatts of output, and we've got the increased voltage range, and it doesn't really make a lot of sense to have the Whoop version 2 and this VTX, and in fact there are solid reports of people receiving this VTX without the casing on instead of the Whoop version 2, and I suspect Cadex will just simply quietly ship this to users now moving forward. It gives you lots of options because you can have it like this with the heat sink, or you can strip it down, remove the heat spreader, but have that Whoop VTX with the extra output if you want to. Now, moving on to the firmware, I'm not going to concentrate on the extras. I'm only going to talk about race mode here. I'm going to cover the other stuff in a future update. Now, race mode is interesting. So, limited to 540p, 25 megabits, low latency. Overall, it looks decent. but there are issues with it. It does highly compress, just like we've seen on the previous firmware versions. And in fact, in my testing, I have noticed quite a lot of distracting behavior around it when it's moving, although I can't comment on how that would be in very, very fast flying. You do, in the greens, absolutely see those same compression artifacts that we've seen on the previous firmware, and it is actually a little bit worse in this firmware than it was in the last one. However, you can clearly see it has pegged the latency a little bit lower. In my tests, and you will find this yourself, it really is keeping it around that 24-25 milliseconds. It hasn't reduced the overall latency down any further towards HD0. It's just keeping it pegged as much as it can until, though, obviously the signal level degrades. It is definitely behaving differently to the original firmware. I can't tell you it's absolutely better or absolutely worse, because the difference here is how much you as a pilot feel variability in latency. That is something racers are going to notice, and it's going to be interesting to see people's opinions on it. There is feedback roaming around from some freestyle pilots that they really like it, so again, it's going to be interesting to see. It certainly isn't anything bad, that's for sure, but it does have some different behavior, and in my testing so far, though, it doesn't quite perform as well from a penetration point of view. Now, with regards to the other things around race mode, we got obviously the race band channels. There are some strange limitations on this. I don't fully understand why you can't have all of the modes available in race mode, because you should just have either the race band channel choice or the normal band channel choice. There's no reason to not give you the normal channels in race band. What you should do is give people the option of choosing both modes, and then you have all modes available, including 540p on the normal mode if you wanted it too. As I did show earlier, though, there is no dramatic change on this system with regards to the RF behavior from the goggles in race band, and that means there are still big limitations around people being able to use this system in a race environment. For instance, the goggles are always transmitting, and they're always transmitting on either the public channel when you power them on, or the last channel you were on if you power down your VTX. These goggles need a way of, when you disconnect the VTX, the goggles power down. They should not continually transmit all of the time, because that is going to cause problems. Overall, I think it's nice to see what they've done. I don't think this is a massive change. I don't think there's anything fundamentally groundbreaking here. However, it is a nice little addition, but I do think they need to continue to work on things with regards to this race mode, and again, open up race mode to all of the modes and let the user just select the channel. Now, one last thing I just want to mention on this new firmware with regards to the version 2 VTX. In my tests, nothing has changed with regards to the RF power behavior. You may remember Chris Rosser highlighted that on the V2, you basically get maximum RF power at the 500 milliwatt setting. That, in my test so far, is still the same. Cadex have not changed that in this new firmware. In my opinion, this is a bug. It is not intentional behavior, and it is something that is still there, it seems. So, overall, that's it from me on this one. I hope you have found the video useful. Please do let me know what you think in the comment section. If you have any questions, put them in there and I will try and answer them as well. Now, I just want to say, if you have found this video useful and you'd like to support the channel, please do consider checking out the links to Buy Me a Coffee and Patreon. It's only through the support of my patrons I'm able to keep making content on this channel, and if you'd like to support us to allow us to keep making content in the future, please do consider checking it out. Anyway, that's it from me on this one. Stay safe. I'll speak to you soon.